Standing waves are difficult to actually see with a metal tube or rod because the amplitude of the oscillation is so small. However, you can actually see standing waves with this activity. Dr. Smith has a roughly 2-inch piezoelectric transducer, capped from a cap of tennis balls and some tape. He centers the transducer on the top of the cap and tapes it in place. Dr. Smith is going to use a frequency generator app he installed on his phone. A frequency generator creates continuous frequencies from 20 Hz all the way up to 20,000 Hz. An amplifier is used to increase the volume or amplitude of the frequencies generated by the frequency generator. Using various audio cables and connectors, Dr. Smith connects the headphone connection of the phone to an input on the amplifier. The output of the amplifier is then connected to the transducer. If the setup is working correctly, you can hear the frequencies generated by the app on his phone through the transducer. The volume must be very high for standing waves to appear, so ear protection is a good idea. In order to see standing waves, Dr. Smith sprinkles table salt onto the cap. Starting with the lowest frequency setting and maximum volume settings, he slowly increases the frequency until a standing wave is seen on the cap. His first standing wave is seen at 1300 Hz. Recall that with standing waves, the object itself is actually oscillating. It is only at the nodes of the standing wave where no movement in the object occurs. Since motion does not occur at a node, the salt bounces everywhere but at the nodes and settles at the nodes of the standing wave.
The nodes are in shapes of circles.
Yep. Now check this out. Higher frequency standing waves have more energy and therefore more nodes. As Dr. Smith slowly increases the frequency to 2600 Hz, we come upon another standing wave. If he increases the frequency even more, a standing wave is found at 5200 Hz. The higher the frequency of a standing wave, the higher its energy and the more nodes it will have.